and in this demonstration I'm going to show you one feature within PSpice Advanced Analysis. That feature is Optimizer, and PSpice Advanced Analysis is a set of tools that sits on top of the regular PSpice tool, allowing you additional functionality that you don't necessarily get within PSpice. So in this demonstration, I'm going to focus on the Optimizer tool specifically. There are 5 features in total in Advanced Analysis. The one I'm focusing on here is the Optimizer. The Optimizer allows you to create multiple goals and try and get your output waveforms to match those goals as closely as possible. So you can enter goals via measurements or actually curves, and you can have the simulator attempt to meet those goals automatically and change your component values to meet that. Let's take a look at how this works in the Capture tool with PSpice and Advanced Analysis. I'm going to start off with a simple demonstration, and in this demonstration we can first off run a simulation and see what the simulation looks like. So here's the results of my simulation right now. I'm taking a look at the noise specifically, but there's a couple measurements that I want to evaluate. If you want to be able to take a look at these measurements, and they are critical for Advanced Analysis, you can go here to View Measurement Results, and that'll bring up this little window down there. So we'll turn it off and turn it back on. And there's various measurements here that we're taking a look at. So the maximum in dB of V load is being measured at 9.4, and some other measurements here are being measured as well. We want to run the optimizer on these measurements to get the values to change by changing component values in our circuit. So let's go back here to our circuit. Here's our circuit, and we want to change component values, but we don't really know exactly which values to change or in what direction to change them or what value they should end up to meet some constraints that I'd like to put on the measurements. To do that, let's go instead to Advanced Analysis and to the Optimizer. This is going to invoke the Advanced Analysis tool that sits on top of the regular PSpice tool. I'm going to invoke that. It's going to open up for me. And what I have here now is the 4 measurements, the same 4 that I was taking a look at in PSpice. And we have a min and max value. So we want this maximum in dB of V load to be between 5 and 5.5. And on the last screen we saw it was about 9.4. We'd like our bandwidth to be over 200. We'd like our noise to max out at 5 and 3 nano for those various measurements. And how we'd like to meet these constraints that we've set up is we'd like to change component R8, R6, and R4. Originally they're these values, and we have a range specified that we're allowing to change them. You can import additional parameters if you want to, but in my case that'll suffice, just these 3 parameters. Once we're ready, we just hit the Run button, and this will take just a few seconds. You can see the progress bar in the upper left-hand corner, trying different iterations and trying to converge on a solution where the error eventually gets down to 0. And you can see that that just takes a few seconds to meet that goal. And when we take a look at this, we can see our original value was 9.4181, and eventually it got it right into the middle of our constraint. So it got it to 5.244, which is right in the middle of 5 and 5.5. Our bandwidth, it got over 200 to 212, and it was able to meet our noise margins here as well too. How did it do that? It changed our component R8 to 3.57, R6 to 702, and R4 to 238. But those components can't really be purchased. They're kind of strange values that you can't pick up at any store. So what we'd like to do is map these to components that you can purchase. So you can map this to resistors on a 5% table, a 1% table, or a 10% table. I'll choose 5%, and then I'm just going to rerun this quickly, and it'll just take one iteration to match these to the closest available purchasable values. So it comes up with the resistors being 3.57, 698, and 240 based on the tables that we have. These tables are provided with PSpice. If you want to make an additional table or make changes to existing tables, you certainly can. You can see that the error is still 0%, so that's great. We're still meeting our error. We can then plug in these current values here into our circuit for R8, R6, and R4 to make it match the behavior that we're seeing right here in the current values. So that's one way that you can use the Optimizer tool, using measurements. Another way you can use Optimizer is using the curve fit. I'm going to bring up a different example, and we'll take a look at the curve fit. All right, in this example, I have a two-stage filter. There's my first stage, there's my second stage, and it's behaving like this. We can run the simulation and see what it is doing. and this is what it's doing. So here's the gain in green, and that's tied to the primary axis over here on the left. So we're seeing about a 40 dB gain across the low frequencies, and then it tapers off as it gets into the higher frequencies. The phase you can see right here in red, and that's approximately up here at between 90 and 180 degrees. And it eventually goes to 0 around here, and then it flips to negative 180 around there. So that's what our phase is doing. But this is not exactly how we want this circuit to behave. We want it to behave differently, and we actually have a text file showing exactly how we'd like it to behave. So I have this text file, and you could have obtained this from any number of different places, from a scope, from spec sheets, or something like that. And you have different frequency, phase, and gain points that you would like to meet in this simulation. So you can zoom through here and see all the points that you have. And these points would essentially make up a curve. And you would like to match your phase, which is the second column right here, and your gain, which is the third column right here, to the waveforms that you see here. So gain is the green trace, phase is the red trace. So that's what we like to match. We can also, I just put this in an Excel graph just so we could kind of see what it looks like. It's the same data, and you can see here's the phase and here's the gain that I would like to be getting for my circuit, which I'm not getting right now. So I'd like to make those map to each other using the optimizer. This is my source. This is what I'd like my waveform to look like, and this is what it looks like now. So I want that to be changed. To do that is actually not that difficult with Optimizer. Without it, it would be incredibly difficult, but with it, it's not that bad. I'm just going to close this one down, and let's go to Advanced Analysis, back to Optimizer. So this is the same Optimizer tool that I was using previously. Now I'm just in the Curve Fit tab. And what I want to do here is point it to that reference file. So that was the text file that I had shown you before. And the trace expression, so this is the trace in the schematic that I want to map. So the voltage in dB of R2 at node 2. So that's my output voltage, and this is the phase of my output voltage. And I want to map this one to the gain and this second one to the phase. I have some tolerances specified, and here's the components that I'm allowing it to change, the original values and the range that I'm allowing them to go to. I'm going to hit run here, and that is going to open up the probe tool, and it's going to show me graphically how this is being optimized. So the red in the top and the bottom are my waveforms that I would like to meet, and the green is the changes that it's making to my original waveform to try and lay on top of that red. The top is the phase, the bottom is the gain. So the top red trace is the phase that I'd like to meet, and the bottom red trace is the gain that I'd like to meet. And it's trying to move that green trace, which is the actual result, on top of the red trace. So it's doing its best. It's taken a few iterations, and now it's actually completed. At this point, it's done, and we'll see in a second that it's met the tolerance. So within the tolerance that we've specified, it has met that. And so the results here are accurate enough. I could decrease that tolerance if I want to and continue running simulations and get this as accurate as possible if that is a requirement. But we can come back here, take a look. The error is now 0%. I have been able to meet my restriction, and my current values you can see right here are the ones that it picks. So that's the value I need for my R6, R5, R4, etc. These are the specific values that I need. I could, of course, run this through the discrete engine again now if I wanted to map those to purchasable components, or I could decrease my tolerance here and continue the simulation. But this should hopefully show you how you can use the optimizer to get incredibly accurate results for both measurement type of optimizers and curve fitting in the optimizer. So you can match to measurements, match to curves, and get results that would be very difficult to obtain in any other fashion. Thanks for watching. I hope you enjoyed. Bye-bye.